Okay, let's go ahead and get ready so that way we can get this foldable done. If you need to, please take your time and pause it, rewind it, so that way you can get all the materials in and make sure you get everything correct, okay? We don't have, this is our last foldable for this semester. Again, though, I just think that the foldables just kind of summarize everything from what's in the notes and just really puts it into a small, you know, A, B, C, D, here you go. Here's what you need to know. And here's the shortcut method of all of it, just kind of combined together. And that's what I like that. Let's go ahead and let's start off with, we need 4 papers. Again, I don't care if you use notebook paper, construction paper, computer printer paper, whatever it is. I just happen to have 4 pieces of paper. Again, we're going to go ahead and fold them like we traditionally have been, like a little book. Okay. Again, if you have, that's it. You're more than welcome. Just leave it like that. I'm going to staple it for myself. After a while, hopefully you notice that these foldables are actually really helpful. They're really good study guides. That's why I like them. Okay, so I'm going to staple this sucker together. If you don't have a stapler, no problem. There we go. So I got me a little book here. Also, please, I need to have Unit 5 Electron. Right, because that's where we're at right now, the Unit 5. It just kind of helps you just that way on the, you know, the top of all the foldables with all the different units. You can just kind of organize them that way. And make sure you put your name down here. So put your name. I'm going to put my name. When you take pictures of the foldable, make sure that they're clear, good pictures that I can see. So that way I can grade it, okay? Since I'm unable to actually get the foldable from you. Okay, if we were in class, you would have to turn it in. So I'm going to go ahead and show you what's going to go on the pages here. Let's go ahead and just number those pages. Again, I really think it's a great study guide to look at. Kind of go through and help you out. Maybe simplify. Sometimes going over some of this new information is just so new to you, you're just not sure about it. Hopefully this is another way to go over electrons and it's going to make sense to you. So we got page 1, page 2, number your pages at the bottom. Page 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14. Okay. So there we go. We got our pages there. Let's go ahead, and you have your printouts already that you got from Blackboard. So get your printouts, and my printouts are in different order than your printouts. So here's what you're going to start off with. You're going to start off with, it looks like, if I can find it, let's see. Looks like this. So we're going to cut it right here. S, P, and D. And I need to cut the edges off so that way it can actually fit inside here. Okay. Then I need this little strip right here. Again, don't forget my printouts are in a different order than yours. I need that little box. I need that little thing there. Then we need the one that looks like this with those little arrows in the box. So there we go. Let's go ahead and get this taped in, so that way you can kind of see and get a picture of what it looks like. So on page 1, okay, I'm going to have to turn it sideways. Page 1. This is going to go on page 1. Glue it in, tape it in, however you're going to do it, but get it in your foldable. There we go. Page 2. So here's page 2. Again, I'm going to have to keep it sideways like this. And looks like I'm missing one more thing. Let me see if I can find it so I can show you. It's going to look like this. So going to need this little strip right here. Ready? So page 2 is going to have this, this, and this. So let's go ahead and get that taped in for page 2. And then this one goes over here, somewhere at the bottom of page 2. Alright, so page 1 looks like that, and page 2 looks like that. We're going to get everything taped in first before we fill in anything, okay? Now let's get to page 3 and then page 4. So on page 3 and 4... we're going to need this 3D6. Alrighty. What else am I going to need? We're going to need the 3 rules for the electron configuration, right? Oops, sorry, that's not it. Here it is. This one, I'm so sorry. The Aufbau principle, the Pauli exclusion, and the Hans rule. That's what we need. So let's get those. Again, I'm sorry, my printouts look a little different than yours. Oops. Now when you cut this out, I'm expecting you to, yes, cut it like I'm telling you to. There should be no excuses. So don't be shocked if I take off points because you didn't cut it out like I told you to. That's a simple task. You're going to cut right here on the lines, and you're going to cut over here as well because they're going to flap up, and we're going to write under them. Okay? So you should have the 3D6. You should have the 3 rules for the electron configuration. We're also going to print, or you printed out, let's see, the pictures of the shapes. It's this little bitty square. Looks like that. And then the actual order of the electron configuration. Remember I told you on the notes, I was like, oh my goodness, there's an order there. And I don't know about you, but I don't have that kind of energy to memorize that actual order. This is the order here. I'm going to show you a shortcut of the order. So you should have 4 things on page 3. Page 3 should have this in this box. Okay? Don't turn it sideways, leave it up and down. And let's get those glued in or taped in, or I don't know what you're going to do, but let's get them in there. Okay? So this one, And then this little square over here at the bottom of page 3. Again, all of this is in our notes. Just trying to shortcut it, simplify it. Page 4. Let's turn it sideways. And we're going to tape this one over here. At the top. And then we'll tape the rules down here at the bottom. And again, make sure that they can flip up so that way you can write under them. I will take off points if you don't do that. So here's what page 3 looks like, and here's what page 4 looks like. If you need to, pause it. We're going to go on to page 5 and page 6. So let's look at what 5 and 6. You're going to need this square that looks like this. You're going to need this square. That looks like that. And then you're going to need this other one that's a little bit bigger. Let's see if we can find it. Nope, nope. Here it is. Let me cut it out so that way I can show you. That one. Okay? So again, if you need to, go ahead and pause it, rewind it, whatever you need to do. But I'm going to keep moving forward and keep going on. Page 5, leave page 5 up and down. If it doesn't fit, then cut it out a little bit more so that way your little square can fit really nice and neat inside that space that you have there. Okay, that one goes at the top. The other square is going to go at the bottom. Like that. There we go. Page 6, this is going to come over here. If you need to cut out, I need to cut this a little bit more so it can fit better. So get that on page 6. Gives you a little summary of the 3 electron configuration rules. Okay. Alrighty, let's go ahead. So page 5 looks like this and page 6 looks like this. Let's go to page 7 and 8. Alrighty. Now on page 7, I'm going to need you to get an extra sheet of some kind of construction paper or something. We're going to make a little pocket on this side. Okay. So you want it to fit the size here. And I'm going to just cut out a little bit here. That way I can see my page 7. So let's get that taped or glued in. Right. It's going to have to be right here along the edges. We're going to fit something. We're going to fit a periodic table in this pocket. That's what's going to go in here. Okay, so. And make sure you glue or tape that bottom side so the periodic table doesn't fall out. I'm telling you right now, next semester, everything looks like it's going smoothly. We're going to go back to class. I suggest that you have some kind of binder and you have Unit 1, Unit 2, Unit 3, Unit 4, Unit 5 all in order, because everything that we do here in chemistry really builds upon it. Okay, and I would have some kind of something, maybe like a sheet protector, and in every single unit, something like this. That way you can open it up and you can put like all your foldables or something. Okay, but I would have my foldables. If you don't have all of your notes, your foldables are like a nice compacted review of your notes or that unit. So have them with you when we start going back. Let's look on page 8. On page 8, you're going to need this sheet. If I can find it. Where'd it go? It's going to say S, P, D, and F block. We haven't talked about that yet. That's our shortcut that I'm going to teach you today. Okay? So, oops. We need to cut that out. Again, I'm expecting you to cut it the correct way. You're going to cut it in the line in between the S, P, and D and F block. Okay, that way they can be picked up and you're going to write under them. But we have to do this periodic table first before this can make sense. Okay, this is going to be taped in or glued in on page 8. Then you should be able to pick up each one and read under it. Let's go ahead and go to page 9. Page 9. You're going to have this one and this one. And I'll show you in just a minute if you can't see it very clearly. Oops, sorry. Again, I'm going to go through most of it, and I'm going to answer most of it with you. There are some things that you're going to have to answer on your own, but most of it I will show you what to write in. Okay, so let's look at page 9. Let's turn it sideways like this, and we're going to tape in or glue in this little block square. Okay? So this one goes on page 9. Okay, now we're on page 10. Again, turn it sideways also. And this one is going to go on page 10. Okay, so there's page 10. Page 11 and 12. Let's look at 11 and 12. All right, here it is. Our formulas in the electromagnetic spectrum are going to go on those 2 pages. So let's go ahead and get those cut out. The equations. Those equations are on your formula chart. If you've looked on Blackboard under the chemistry work, where it says chemistry work, then it pops up with all those folders. Before you hit any folder, at the top is what we have, the chemistry formula chart, okay? Also, those equations right here are on your notes. But here again, this is like a summary to kind of help simplify and shortcut everything, I'm hoping. All right, so there's the spectrum. So on page 11, I'm going to need to turn it sideways. And this one's going to go on page 11. So there you go, so you can see. Tape, glue, hot glue, stick, I don't know what you're going to do. Do something, but get it in. right, so here's our, and we need to have these constants, those numbers there. I mean, I'm not sure about you, but I mean, memorizing so many numbers, it becomes a lot. There's no need for it. It's in the formula chart. Okay, and look, it's here for you. On page 12, here's page 12, you're going to tape in, glue in the spectrum. So get the spectrum in there. Here we go. Here we go. All right, let's keep going. We're on page 13 and 14. You should be down to the last bit of it. This part goes on 13. And those other questions are going to go on 14. I'm going to have to cut it so I can make it fit onto my little booklet. Then here's the last bit of it over here. Oh, yeah. Okay, this one's going to go on 13. So please take a look and make sure you fit it on 13. Get the right one on 13. Get the right correct one on 14. So that goes on 13. This one goes on 14. Then we're done with all those pages now. You should have everything glued in, taped in to the correct location. Now let's go ahead and let's fill this stuff in. Okay, so there's 14. Again, you can always pause it, rewind it, whatever you need to do. But we're going to start off on page 1. Okay, I've got this filled in over here. So to kind of make it go a little quicker, I'm going to show you my pre-done. All right. Some of it's not pre-done, but page 1 and 2 are. So here's my original copy of my foldable. So on page 1, there you go, making sure that you can see it. The exact position of electrons are not known. To be honest, if scientists really try to stop and grab an electron out of that atom, and they've done all the calculations and math and figured out exactly what atom or what molecule they have, when they try to go and find it and grab it, it's not there. And that's the weird thing about electrons. Electrons, we know, can jump from orbital to orbitals, okay? And the valence electrons, not only do they jump around and move, but they actually bond with other atoms that are near them, and that's where chemical reactions are taking place with those valence electrons. But the valence electrons are not allowed when they're traveling or moving from orbital to orbital. Let's say they're going to move from the purple section to the yellow section. They're not allowed to be here and literally like travel and move over here. They're not allowed to do that. So how does an electron go from the purple section to the yellow section? It literally is here, disappears, and reappears over here. And that's what just blows some of the scientists away. Like, this is just crazy. You know, you would think that if you personally were to have to go, you're going to the mall. You're going to get in your car and you're going to drive along the road, the highway, till you get to the mall. And so if we really wanted to track you or find you or have a helicopter above you watching you from the ground, we can see you in your vehicle driving along the road. Okay, but electrons don't do that. If you were an electron, you were at your house and you were going to go to the mall that's located somewhere over here, you would get in your car, literally disappear, and then reappear. It's like you teleported. And that's the weird thing about electrons. It's like they teleport, okay? So do we know? It's not really known. Now, we have what we call probability, okay, or the chance of where it's going to be, okay? And the probability or the locations are what we call probability clouds or atomic orbitals, okay? Now, the probability cloud, when we use that word, it's the pattern of electron positions plotted over time to show the likelihood of an electron's being at a given position at a given time. Normally, this is how they're going to spin. This is how they're going to rotate. This is where they traditionally are going to locate or be at. The atomic orbitals is a region of space, all right, those shapes that we were talking about, right? Some of them are spheres. Some look like, we call them dumbbell or flower shapes, in which the electron in an atom has a 90% chance of being located. Orbitals have different shapes, right? The atomic orbitals are the shapes, those S, P, D, and F shapes. Now, the electron configuration is an arrangement of electrons in the orbitals of an atom. Each orbital can hold up to 2 electrons, and they must spin in opposite directions, spin up and spin down, if they're going to be in the same orbital. Okay, next one. Example of orbital diagram. Okay, this is what we called electron configuration. This is the orbital diagram. So if I need to, let me go ahead and write that in to clarify that for us. This right here is what we call the electron configuration. Okay, this right here is what we call the orbital diagram. So when you're asked to write the electron configuration, you're writing this. When you're asked to write the orbital diagram, you're drawing the arrows. Okay? Let's keep going. Now, I told you in your notes, and I can pull out the notes. I have them right here. Okay? But there's a section in your notes that look like this. And look, okay, the electrons enter orbitals of lower energy first. Here is the order they use. All electrons go in this order. Every single one from the periodic table goes 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5. Now, again, though, that big number is going to be the energy level. It goes from energy level 1, 2, 3, 4, 5. But Miss Munson, why is it that you go from energy level 1, okay, to 2, to 3? Doesn't that make sense? Then wouldn't you go to a 4? And then why do you jump back down to a 3 and then jump back up to a 4? Some of this doesn't make sense because it's not in numerical order. Well, I get you. And the reason why this doesn't make sense is because some of these orbitals overlap each other. And when they overlap each other, believe it or not, it takes less energy, okay, to go to a 4s than it does to a 3d. Because the 3d is further away from the nucleus. Alrighty? And it takes less energy to go to a 5s, which is a bigger number, than it does to a 4d, which is 4 is less than 5, okay, because 4d is further spaced out from the nucleus of that atom. Now, there is a shortcut way to learn this, because I don't know about you, but I don't have the time to memorize this order that's not in numerical order. I mean, it would be easy if it's 1, 2, 3, 4, 5, 6, 7, but it's not. So, here is our order. Please write this in. The order that electrons fill. 1s, 2s, 2p, 3s, 3p, 4s. Do you see those boxes? Those boxes represent, it's kind of like, remember I told you like the seats in the bus? We can think of it as, why don't we think of it, some of us may not get the seats of a bus. What if we think of it as a hotel? This is one hotel. This is the first floor. And the first floor of the hotel has one room. And in that room there's one bed, and 2 electrons can sleep in the same bed. Now, they don't like to sleep there because they just don't feel comfortable sleeping right next to another electron. So what they do is one sleeps this way and the other one sleeps this way. They sleep in opposite. Okay, and they fill it from the bottom before they're allowed to go up. These electrons can't just go up to the 7th floor if they want to. No, they have to fill the 1st floor and the 2nd floor and the second 2p floor and then the 3s floor. They have to go in this order. Why? Because it takes less energy versus more energy. And electrons are pretty smart. They don't want to use up all their energy, so they're going to go into the lower levels first with the less energy before they traveled higher up. Now, remember how we said that the S, P, D, and F are those shapes? And this is what the shapes look like. The S looks like a sphere. The P, they have it looking like two like ovals. Some places or some people say that the P looks like these two little, like, they call them dumbbells. Okay. The D looks like kind of like this weird flower. 1, 2, like 4 petals on a flower. And an F looks like 8 petals of a flower. Okay. The amount of electrons that can fit into an S orbital is only 2. Okay. There's only one bed. And 2 electrons can fit in there. Now in the P though, look right here. There's 1, 2, 3 beds. And 2, 4, 6 electrons can sit in there or lay down and go to sleep. Just like I used the example of seats on a bus. The D, look at the D, has 5. And so 10 electrons can fit in there. Each one of these are orbitals. 1, 2. The D has 1, 2, 3, 4 orbitals. Do you see what I'm saying? That's an orbital. Okay. Where am I at? I'm sorry, I stopped for a moment. 6, 7, 8. 1, 2, 4, 6, 8. So let's keep going. My pages aren't numbered. Sorry, I got stopped for a moment there too. Let me number them. 1, 2. We just finished 3. Let's go to 4. We had to turn 4 sideways. I'm expecting you, everything that I have written in, I'm expecting you to write in as well. So it's in our notes. 3D6 for an example, and it's on page 2 in our notes over here is where it is. So the big number in the front